Okay, so here we have another string dealing with the multiplication of fractions, and we're going to highlight in this string a great property which allows us to simplify a lot of multiplication expressions, where we can switch numerators and change the order, and I'll explain what I mean as I work through this. So the first thing we're going to do in this video is use a standard algorithm to figure out the product of each expression. So that means we're going to multiply the numerators, the top numbers, over the denominators in each case. So this will be 1 over 15. The next one we have 2 times 1 in the numerator and 3 times 5 in the denominator. That gives us 2 out of 15. And that makes sense because we're just going from 1/3 to 2/3, so this should be a little bit larger. And here, 2/3 again, but now we also have 3/5. So we have 2 times 3 over 3 times 5, and that gives us 6 out of 15. And then last here, 3 times 2 over 3 times 5 gives us the same thing. So now, let's think about why these two are the same. Right? How could it be that 2 over 3 times 3 over 5 is the same thing as 3 over 3 times 2 over 5? To help us understand that, we're going to look at an array. So this is going to be a 3 by 5 array, giving us 15 squares in the middle. I think I can estimate that. I'm going to use my line tool right here. 3 pieces vertically, and then 5 pieces horizontally. Now, this is a little bit off, but every square here should be identical. That's the fractional pieces. So in the first case, we have a 1 by 1 out of 15, so it might encompass one little square out of 15, and we can represent that one. The next one, we hit 2 squares out of 15. Now here, somehow, 2 over 3 times 3 over 5 gave us the same thing as 3 over 3 times 2 over 5, and let's think about why. So our strategy so far has been to take these two numbers, multiply them, and put over these two numbers here. Okay, well, 2 times 3 could encompass an area of 6 squares, right? These 1, 2, 3, 4, 5, 6 squares out of 15, so that would give us 6 out of 15. But if we think about it as a 3 by 2, right? If we go, we'll use blue here. 3 by 2, we get this blue square here. Let me use a thicker marker there. Just more. So we have this blue square right here, or this red square. Go back over that one. So either the blue square or red square, regardless of the order, give us the same size rectangle, right? A rectangle with an area of 6. And this tells us that we have to get the same answer. And all we did was switch the order of the numerators. First we had 2 times 3, now we have 3 times 2. And why is this so great? Well, because if you're given a problem, if you're given a problem like 2 over 3 times 3 over 5, and more complicated problems, before you multiply, you can notice that you have 2 3's right here. So if I move this numerator here, and I put this numerator here, in fact this problem becomes much easier. Before I even multiply, you might realize that 3 over 3, that means 3 divided by 3. And what is any number divided by itself? Well, that's 1. So really this problem is just 1 times 2/5. So the answer here is 2/5, and that is exactly what these two are if you reduce them. If you divide 6 and 15 by 3, you get 2 out of 5, and that's the answer. So the point is, when you're multiplying, look at the numerators. Look to see if they match any other denominator, or perhaps they're a multiple or a factor of a denominator. It might simplify to make this problem a lot easier. So for example, if the problem was 2 over 3 times 6/5, well, this is nice again because 6 is a multiple of 3. If I change the order of the numerator and move this here and move the 2 there, I get 6 over 3 times 2/5. Well, 6 over 3, that means 6 divided by 3, and that's just 2. So 2 times 2/5. Much easier to think about, and we get 4/5. So this strategy can really help you when you're working and multiplying out fractions.